let's head into some probability, shall we? And for this question, very strange. Okay, well, whoa. For this question, we're really just relying on one formula. So let's go for it here. If PA equals 0,3 and PA or B is 0,9, determine PB, probability of B, if events A and B are mutually exclusive. So we've got this formula that we looked at on the first page, and you'll see it in the formula sheet of PA or B equals PA plus PB minus PA and B. And we made sense of it before. I think it's just useful having kind of that diagram of what does this formula mean. It means we've got two events A and B, and we're looking what's the probability of one of them happening, which means that we're basically highlighting, everything in both of these circles. So clearly it's the probability of A, well, it's the probability of B, but we've double counted the circle in the middle, which is probability of A and B. So in this first question, what we're told is that these events are mutually exclusive, which means that this section in the middle here is actually 0. So how you may draw this in an Euler diagram is to draw it like this, A, B, where there's no overlap because there's no probability. So if we just use our beloved formula here and we say, well, this part here is 0, so in other words, we can just subtract it because we're subtracting 0. And fill in the bits of the equation we know. A or B is 0,9, probability of A is 0,3, plus the probability of B we don't know. Well, think that 0,9 are both of these things together. So therefore, if they both are 0,9 and one of them 0,3, the other one must surely just be 0,6, right? Because you're adding them together to get 0,9. So kind of there it is with the formula, but that picture, kind of that visual in mind is useful. Okay, determine PB if events A and B are independent. Picture doesn't help us as much anymore, but we're going to use the same formula. So for part 2, what we're going to do is say, well, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B, right? So that's our formula. And we know some of these things. So we know A or B, that's still 0,9. Probability of A hasn't changed, 0,3. Probability of B, we still don't know. We're trying to figure out. But we're not told directly probability of A and B. But because we're told that these are independent, it means that A and B is the same as the probability of A times the probability of B. That's the embedded bit of information. Now we've got a formula to solve. So let's subtract 0,3 from each side to start with. 0,6, maybe look that spirally thing, look at it, because 0,6 equals probability of B minus 0,3 times the probability of B. And maybe a little time sign there. Now, different ways to solve this. One obvious way that comes to mind is that you kind of take the probability of B out as a common factor, and so you're left with 1 minus 0,3, which is 0,6, and then divide both sides by 1 minus 0,3. I'm going to show this in-between step equals probability of B times, well, 1 minus that is 0,7, and perhaps you may have seen that as well. Well, we've got one of these probability of B minus 0,3. We've got 0,7 probability of B. Doesn't really matter. The point is that we divide both sides here by 0,7. What you do on one side, right? And, well, pop that into the calculator. So it's 6/7. I sometimes like to just kind of have it as a fraction. But then, this is approximately equal to calculator. Oh, we still got it going all funny. I like that. Oh, no. Oh, I enjoyed that funky look. So we got 6/7 or 0,6 over 0,7 as a decimal, 0,86. Let's go to 2 decimal places. That's how we're feeling. Okay, so that's that one. And, enjoy. Where was our thing?